Hello and welcome to part 2 of lesson number 3 in Unit 1 Functions in our grade 11 University College Math class. This is Domain and Range. And we started with an introduction to sets of numbers. We'll need those as we're articulating what our domain and range will be. We started with an explanation of domain. Just as a recap, domain is talking about all of the horizontal or x elements of a relation. And what that really means is like what x values are eligible or can we use in this particular relation. We can articulate domain in words as a number line or in a set notation. We're going to be focusing on me, and unfortunately what would have been you, using the words. Number line's kind of our entrance into figuring out what domain is, and set notation is what we'll be using throughout the remainder of the course when we're trying to say what the domain and range will be of a particular function or relation. So there's this long set of words. Each of these sets of words corresponds to a symbol in our set notation. So we've done 2 examples. I'm going to just bump right on to the third since I sure hope you've watched the first video. So here's another number line. Again, let's sort of get in there and figure out what's the important pieces of information here. So the first thing I want to note is we have this nice actionable point right here at -2 and another one up here at 3. What else do we notice? Well, right off the bat, we'll notice that we've got these continuous lines happening here from -2 to -1, -1 to 0. It's continuous, and what that means is, again, every little tick on this line could be a part, or I guess is a part of the domain. So that means it's not just -2 and then just boop, bump over to -1. It's also -1.3 repeating. It's also -1.000006. It's all these little numbers are included by this solid continuous line between the points. So what kind of number set is that going to be? It's going to be real numbers, of course. And last but not least, we want to be looking at what types of circles we have at the beginning and end of our domain. Well, we see an open circle here, and that's going to mean that it is doesn't include. It doesn't include this point. Goes right up to it, but it doesn't actually include. Whoops, it's not a letter. There we go. Doesn't include 3, and similarly doesn't include -2. But it gets right up to them, as close as you could possibly imagine. So we're going to now write our domain. Again, we're going to do the set notation. So let's start it off by opening the set of all x such that x is an element, as we've decided, of real numbers, and now we're going to set up our conditions. Our low end relevant point is -2. We're talking about x, and our high end point is going to be 3. So we know that x will be, so our domain will be less than 3, but not equal to it, because it's an open circle. Similarly here, we have -2 is going to be less than x. And again, I know this is a bit of a hard one, even for me, is that x being greater than but not equal to -2 is equal to this representation here. The reason we have to do it like this is we need to have our entire set of conditions in one I guess one statement, one mathematical statement. So although this is equal, we'll be not writing it like that, we're going to be writing it like this. So there is our domain. That's the introduction to domain. Now we're going to jump over to range. And as you can imagine, the range, sort of like a complement to the domain, deals with all the vertical elements of a relation, and that is the y variable, also based on the way that we've been moving in this course, also maybe f at x, the f at x axis, what is happening to our function at an input value from our domain of x. But we'll keep it as y for now. So we have domains for x's, that's the horizontal stuff, range is for the y, and that's the vertical stuff. Again, like domain, range can be described in words, as a number line, or in set notation. We, again, will be focusing on the set notation and saying the words that lead to the set notation that correspond, but I'm going to write it out here once. So we're going to look at this first example, and we have a number line here. So as with domain, let's get a look at some of the action points on here. Well, our action point, we can see, is going to be -1. And and then it just goes on sort of forever, so we don't have sort of an upper limit, I guess. Now, what kind of numbers are we dealing with here? Well, you can see that this is a continuous line, a constant line going all the way through. That means it includes not just 0, but also 0.1, 0.11113, 0. You know, it's all of it. It's all in there, which means that we're going to be dealing with real numbers, which is cool. Last thing we want to notice here is that we have an open circle. So that means we're going to get all the way up to, but not actually include, -1. So let's write out set notation the long way first. We're only going to do it once for each. So here we go. And it's the same, obviously, with a few substitutions. So the set of all, instead of x, we're going to be talking about y. Set of all y, where y is an element of real numbers. Man, this takes so long to write. I'm so sorry. You get to see me do it in real time. How great is that? Set of real numbers where, and now we're at our conditions. This where here is the comma, and now we have where y is greater than -1. And that's the end of it. You'll notice that we're not saying greater than or equal to, because it doesn't actually get to -1. And again, there's no upper limit, so it's not going to be less than anything. So there we have it. Set of all y, where y is an element of real numbers, where y is greater than -1. So we can see that we've got it there. Let's now write this out in set notation. So we would write this out as, and again, saying the corresponding words, the set of all y, such that y, oh, sorry, that should be such that up here. Whoops, sorry about that. Set of all y, such that, there we go, apologies. The set of all y such that y is an element of real numbers. Again, real numbers because we have a continuous number line. Set of all y such that y is an element of real numbers where y is greater than -1. And there you have it. There are words in set notation. Thankfully, from now on, we'll just be doing set notation. So let's jump in and have a look at another example here. So we have something different. We haven't seen this one before. Oh, sorry. As I was thinking of it, I also want to mention that when we're talking about greater than or less than on a vertical number line, just think about the way that the numbers are going. As you head upwards into positive values, that's going to be greater than, and as you head down into negative numbers, that's when you're going to be less than. So if that helps. I think for whatever reason it's easier for us to visualize it or get into it when we're talking about horizontal number lines. Okay, here we go. So let's find our actionable points. Here we have one right here. This is at -2, and we have one up here. This one's at +1. And I colored in that line, that dot I should say, and it was a filled in dot. Okay, good to remember. So this is a little bit of a different one. This time we're talking about, again, what kind of numbers here? Well, this part's the same because we have these nice continuous lines, so we're going to be dealing with real numbers, which is cool. If we look at the limits imposed on this first one here, we're talking about all values that are going to be, again, we're heading upwards, so that's going to be greater than or equal to 1. And as we head down away from -2, we're going to be less than and equal to -2. So here we go. Let's not write the words out. Let's write out a set notation. So it would start with, as always, the set of all, in this case y, because we're dealing with range. It's the set of all y such that y is an element of real numbers. That's for the continuous lines. Where, now again, what's unique about this example compared to all the other ones, if we look at the first example in range and then the 3 examples that we did in domain, they've all been sort of inclusive. They haven't been broken up into 2 pieces. Because this one is broken up into 2 distinct pieces, we are going to make 2 sets of specific conditions. The first one, of course, where y is going to be greater than or equal to 1, and the second, where y is going to be less than or equal to -2. So this is the time that you would do this. Not when you have sort of one little chunk of domain and range that has an upper and a lower limit. We're really just talking about sort of one continuous line. This one here, the example we've just done, has 2 continuous lines starting from different places. So that's why we write the range this way. Hopefully that makes sense. Now we're going to bring domain and range together. So we're going to be doing 2 at once. So here we have, let's start by looking at this one right here. Now, what I'd like you to imagine is this point here, all the way along this continuous line up to here. What I'd like you to imagine is that is our relation, or function, but we'll call it a relation for now. So this is a relation. It's on the graph. We're trying to find the domain, i.e. which x values are going to work for this thing. Which ones are eligible and which ones are not. So what I'd like you to imagine is if you were to take your sort of hand, and I'm just going to sketch it in quickly, 3, 4, 5, and you were to push this whole function down flat onto the x-axis. So let's erase that gross hand. And imagine that I've squished this whole thing down just flat. So here's a point, again, just sort of falls down to the line. And here's the other end, goes straight down, and then it covers all of this stuff in between. Well, all of a sudden, this now looks like a number line, and it's something that we can articulate. We have here some actionable points to look at. Again, I'm just looking at the part that's on the, whoops, that's not what I wanted to do. We're just looking at the part that's on the x-axis. We're not focusing on anything else. The function itself has been mushed down, so we don't need to focus on it any longer. We're looking at the mushed down part. We can see the actionable point here is at -2, and we can see that the other one is at 1, 2, 3, 4. So we have this upper and lower. We know that this is going to be real numbers because we have a continuous number line. So let's go about writing out our domain. So we would say the set of all x such that x is an element of, because continuous line, real numbers, where, so my low point was -2, we're dealing with x, and my high point is 4. Well, actually I got a little bit of space here. High point is 4, and then we close the set. So we know that the x values are going to be less than and equal to 4, because we have a closed circle, and that -2 will be less than or equal to x, and again, because we have a closed circle. So that's how we consider looking at the domain. Let's have a look at the range. I'm just going to sort of tidy this up a little bit, because when we're talking about the range, I'd like you to consider that we're doing something similar here. Again, I'll just draw the range in with these colors, or this color. So now what I'd like you to do is imagine you've got your hand, 3, 4, 5, and you're going to be pushing all of this relation, and same thing, we'll get another hand over here, 1, 2, 3, 4, 5, and we're going to be smushing it up sort of against the y-axis this time. So you can see that you'd have a point here, that's the low point, we have a point up here at the top, and if we were to mush it, we'd have this entire thing here kind of sort of like a solid line happening on the y-axis. So let's get rid of the hands. Let's unhighlight the function itself. There we go. So you can see now we've got a range that looks like our number line that we were doing when we were working with range. We can see some actionable points here. We see one at 1, we see one at 2, 3, and 4. And we see that those are solid dots. So these are solid dots here on the line. So let's go about articulating the range. So the range would be then the set of all y, such that y is an element, again we're dealing with here real numbers because of our continuous line, where, so our low point was 1, we're dealing with y's, our high point was 4. We know that the y values will be less than or equal to 4. And again, just to sort of talk through that, basically what we're saying when we say that is like there's no values up here that we can count. Nothing bigger than 4 is going to be counted for us in our range. And similarly, nothing less then 1 is going to be counted. And we articulate that by saying 1, whoops, that's an eraser, 1 less than or equal to y. So we have tackled domain and range for our first example. The next 2 examples are going to be a little bit different. We'll have a look at those in part 3 of this video, so we'll see you in part 3.